Good morning, guys. This is a quick video I wanted to make for you guys because we're not going to meet for another couple days. So what I did is I posted some homework online on Edmodo. Please do that. I will collect it at the end of the week or when we meet. For the time being, what I want to make sure is that we stay on task with what we're supposed to know. So there's basically 3 chapters that we really need to nail. As they will be on the next exam, next unit test, because this is coming up very soon. So the first chapter is chapter 7. This is actually what you have to know to be able to solve the classwork. So I'm just going to give you a quick rundown of the 2 main concepts, all right, in this particular videos, and you'll get other videos as well, one related to chapter 8, Pythagoras, and then chapter 9, trigonometry. But for now, let's focus on chapter 7. For chapter 7, you have 2 main concepts that you have to understand. One of them is called congruency, which basically is a statement that is saying something about the relationship between 2 shapes. What I mean by this is if 2 shapes are exactly identical, same sides, same shapes and everything, in this case we call the 2 shapes to be congruent because they are perfectly identical. So if it's ever said that 2 shapes are congruent, that would mean that all the sides and all the angles are absolutely equal to each other, meaning that shape 1 and shape 2 will have the same length of sides and the same angles. So the statement for congruency looks like this, the little equal sign with a little bar on top. So let's try to look at this example and see if we can solve this. This is a basic example, to be quite honest. I'm sure you guys can show your knowledge on a higher level. But let's take these 2 triangles. It says already that triangle ABC is congruent to triangle DEF. So I locate my triangle ABC, and then I locate my triangle DEF. So I have these 2 triangles, and I have that statement. Now, if that statement is correct, that means that side AB will be equal to the side DE. The side AC will be equal to the side DF. And finally, the side BC will be equal to the side EF. Now, this is where it's really important to write that statement correctly, or at least if it's given to you to read it precisely, because the statement, the order of the letters, tells you which sides corresponds to which. That will avoid a lot of mistakes. You actually may, as well, on your paper, make little notations on your diagram to say that, okay, these sides are equal, and it will help you identify what is the side you're looking for. So in this case, the side we're really looking for is AC. That's the only one that's not given to us. So according to this, AC, according to my new statement, AC and DF will be equal to each other. So all I have to say is, oh, since my 2 triangles are congruent, corresponding parts of 2 congruent shapes are congruent. That means they're equal. So corresponding parts are equal. So DF will be equal to AC, as stated below. So we can now write that this side will be 12. And that's pretty much it. So in terms of congruency, they're going to ask you basically 2 types of questions, or maybe 3 types. One of them will be state why the 2 triangles are congruent or not congruent. So you have to explain why you can establish congruency or not, given the information that you have. Another question may be, what do you find a side? We have two congruent shapes. Can you please find one of the sides? So we're going to have to use the corresponding parts of 2 congruent triangles to identify this. And the last one, which may be more complex, but I've seen it in some books. Sometimes they ask you, what additional information do you need to prove that 2 triangles are congruent? That's a bit more complex. It's a bit advanced level. But I'll let you guys think about it, and we're definitely going to go over this during this week. Now, moving on, I would like to go over the next topic of chapter 7, which is slightly more difficult. It's the concept of similarity. Now, these 2 are very close to each other. That's why we compare them. Congruency and similarity, obviously, if we compare them, that means that they are in relation in one way or another. So the only difference really between congruency and similarity has to do with the size of the object, the size of the shape. So 2 shapes could have exactly the same angles, meaning that they have exactly the same shape, but one may be bigger than the other. that would basically contradict the statement of congruency. We cannot say two shapes are congruent if the sides are not equal. But we cannot just say that, okay, they're not related. They're still related. Sometimes you have two triangles or a quadrilateral that has exactly the same angles as another one, meaning that they are connected in a way. And in fact, they are. Because when two shapes have exactly the same angles, what we see is that the sides are proportional as well. So this is something that we can use to basically calculate new distance or new sides or whatever it may be that's being asked. So right here we have a shape that's quite interesting and quite classic. This is something that we're definitely going to see more than once. So what I have is I have two parallel lines right here, BC and DE. Those two lines are parallel. The reason I know this is because I see the little arrow right here. And then I have point A, and I have these two lines that basically cut both my parallel lines. And that actually creates two triangles. I have triangle ABC right here, and I would have triangle ADE, basically a little bit bigger than the triangle ABC. Now the big question is, how can I figure out side BD and side CE? And even before that, we should ask ourselves this question. Can we solve this? Can we actually find the distances, the length of these two line segments? The answer is, it all depends. It depends of the relationship between these two triangles. If they are similar, by definition, yes, we can figure it out. And the reason being is that the sides are going to be proportional. But if it's not similar, then it's going to be very difficult for us to identify what is what. We could, but that would require high-level math, which we don't really see too much in grading. So, how do we figure out if this triangle, these two triangles, are actually congruent, similar? So, what we have to look for is the angles. Are all my angles equal? So that's what we're going to study. So, for the first angle, I'll pick angle A right here. And I see angle A in both ABC and ADE. And that angle is the same. So, at least one of the angles will be exactly equal for these two triangles. Now the question is, what about the other two? So for the other two, what I'm going to use is a little bit of geometrical knowledge. I know that when you have two parallel lines, just like BC, just like DE, and you cut it with one straight line, angles will be equal, meaning that angle B will automatically be equal to angle D. Now that we have this, it's actually quite reassuring in a way, because we have angle A is the same for both triangles, and angle B is the same for both triangles. Now we can look at it two different ways. First way is if two angles of a triangle are the same, well, the third one has to be the same, because they always add up to 180. Or we can still go with the geometrical knowledge and basically replicating what we just did here on this side. So, two parallel lines are cut by this straight line, meaning that angle E will be equal to angle C. And there you have it. You have the statement ABC is similar to ADE. And I'm not sure if you can see it well on your screen, but if you compare this sign right here, that means congruency, to this sign right here, well, the little wiggly line on top of the equal sign is basically the difference. If you have a straight line above your equal sign, that would mean congruent. If you have a little wiggly line above my equal sign, that would mean similar. So now that these sides are similar, well, all we have to figure out is what is the enlargement factor from ABC to ADE. So what we have to use is we have to use two corresponding sides and see how they are connected to each other. What is the ratio between them? So I will pick my number 12 right here, which obviously corresponds to my number 18. And to get from 12 to 18, what we have to do is we have to multiply by 3 over 2. You can take a second and do it at home, but 12 times 3 divided by 2 will give me 18. Now that we have this, well, we can basically use this scale factor to figure out the other sides. Now the problem is this. We cannot find BD that easily. We could, but it requires a little bit more math, technically speaking. So how about we just find AD which is basically the enlargement version of AB, and then figure out BD from there. So if AB is equal to 10, you will take 10 and you multiply it by 3 over 2, which will give you 15. So this whole side AD is equal to 15. In other words, BD has to be equal to 5. 5 plus 10 will give me 15. So we have one of the sides figured out. And the last thing that we really want to work with is CE. But again, same problem happens. How do we figure out CE on its own? It's much easier to figure out AE, which is the enlarged version of AC. So you take AC and you multiply it by 3 over 2. And when you do that, what you get is the value 9. So basically, this enlarged side will become 9, meaning that 6 plus whatever will be 9. CE has to be equal to 3. And there we have it. So how do we work all this out? Well, these are basically the mentality that you have to have. First, what do we know? So, do they tell me it's congruent or similar? Do they give me some information about angle and sides? All this may come into play, so we really need to identify this. Once you have this, let's read the question. What is the question asking you? Are they asking you to prove congruency? In which case, well, congruency, we have to prove that the sides are equal. If we can do that, then that's it. We're good. If we cannot do that, then we cannot prove congruency because we need all three sides. Well, not necessarily, technically speaking, but we're going to, for the sake of the example. And for similarity, well, if they ask you, how do you know this shape is similar to this one? Well, we have to figure out if the scale factor is respected for all the sides. Now, if they tell you that it's similar, and they ask you to calculate the sides, well, then you simply have to identify the scale factor and calculate the sides. But either way, this is it for this lesson. And I'll make sure to post something about Pythagoras and the converse of Pythagoras, and also chapter 9 with trigonometry. All right, guys, make sure you send me any questions if you have anything. Yeah, stay safe and keep me posted. Ciao.